Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 61 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to begin to use functions on your Raspberry Pi Pico W in Micropython. Now, this using functions is something that is a part of a bigger topic, which is called modular programming, or even we're going to go all the way to begin to do some object-oriented program. Now, what is the concept behind modular programming or object-oriented program? And that is, as our programs begin to get more complicated, to begin to make them more organized by creating little snippets of code, little modules that do certain functions. So if we want to do a certain thing, we call this module that we wrote. And if we want to do something else, we call this other module that we wrote. And that allows us to begin to get more organized and make our code easier to edit, easier to debug, and easier to let other people use it because we are organizing things in modules. And that's what I'm going to do today. I'm going to show you how to implement functions in Micropython. Now, what is a function? A function is a little snippet of code, a little block of code that does a very specific job. And when you want to do that job, your main program calls that function. The function does the job and then returns a value or does something else interesting. So that's what we're going to do. And we'll come over here, and what you guys can do is you can go ahead and let me get out of your way. Go ahead and get a sip of coffee. And I've just created kind of a simple demonstration because as I'm teaching you about functions, I don't want the program to be that hard. And so what I'm going to say is, let's just think about a rectangle. And in your main program, what you're going to do is you're going to define a rectangle. And then there are three things that we want to know about that rectangle. We want to know what its perimeter is. That's the distance around the outside of the rectangle. We want to know the area of the rectangle, and we want to know the length of the diagonal of the rectangle. And so we want to figure out those three things. Well, let's start by just writing a program to do that the old-fashioned way, and then we will move that old-fashioned way. We'll modify it to show you how to do it with functions. Sound good? I hope it does. So let's come over here and let's just jump right in. And we're not going to, excuse me, we're not going to really be doing anything with circuits or anything attached to the Pi Pico initially, and later on we'll start incorporating components and things like that. But we're just going to start out with just writing a program. So what do we need? We are going to need a while loop, and so we're going to say while true. When it's true, true. True is always true. We are creating an infinite loop. And now if we're going to have a rectangle, we need to know what? We need to know the length and the width, and we're going to allow the user to define that. So we are going to say, excuse me just a second here. Let me do a little Windows management. Let me do a little Windows management here, and give me just a second. Okay. I think we are almost ready to go here. I've just got to get things where I can see them and you can see them. Okay, there we go. So we're going to need to get the length and the width from the user. So I'm going to say L for length is equal to, well, the length could be 3.25. It's not necessarily a round number. And so I'm going to float the input so I can get the in-between numbers. And then what do I want? I want input from the user. I'm going to need a prompt. So I'm going to say, what is the length of your rectangle? Like that. Okay. I'll put a question mark, a space, and then close the quote. And then I'm going to close the input and then close the float. If I have length, what am I also going to need? I'm also going to need width. And so I'm going to say W is equal to float. Very similar, input. And then what is the width of your rectangle? Like that. And then space, quote, close the input, close the float. Why do I put this space here? So that when you answer it down in your serial monitor, when you answer it down in your monitor, it doesn't run your answer into the question. It just makes it a little bit nicer formatting. Okay, well, how would we get the area? We would say the area is equal to simply the length times the width. That's pretty easy. What is the perimeter? That is equal to the distance around the outside. Well, how would we do that? Well, I have a length and a length. I have two lengths and I have a width and a width. I have two widths. And so this is just very simple. It is 2 times the length plus 2 times the width, like that. Now, how do I do the diagonal? Well, I've got a length and I've got a width and then I've got the diagonal. How would I get that diagonal? Well, we would use the Pythagorean theorem, which is a squared plus b squared is equal to c squared, the hypotenuse. But I don't want c squared, I want c. So c would be the square root of a squared plus b squared. So how would we do that? I don't know if we've done powers very much, but I don't know if we've done powers before, raising something to a power in Micropython, but I'll show you. It's really easy. It's like almost like it is like you used to do it in Fortran. So if I want to take the length and I want to square it, I would raise it to the 2. Well, what you could do is you could do that like I think in Excel you would do it with the caret like that, but in Micropython you do it with the star star. So it's length star star is raised to the 2 plus width star star raised to the 2, okay? Now, length squared plus width squared, that would be the diagonal squared. But do I want the diagonal squared? No, I want the diagonal. So what do I need to do? I need to take the square root of that. What is the easiest way to take the square root? Is to raise something to the 1/2 power. And so how would I get this whole thing to a power? It would be star star. And then what would I want it to? I could say 0.5 like that, or I could say raise it to the power of 1/2. And just to be sure that that doesn't do integer math, I'm going to put points there. I think in MicroPython it would give you 0.5, but in a lot of programming language, 1 without a decimal divided by 2 without a decimal would do integer math and would give you a 0. So I always like to put the decimals in this case just to be sure. Okay, so I've got this thing solved. So now I'm just going to do some print. So I'm going to say print your rectangle information. Okay, and then close the quote, close the print like that. That looks good. And now I'm going to say print. What do we want? We want the area and then a colon and a space. And then what do I want to print? Area, like that. Okay, now print. What else do I have? I have perimeter, colon. This was very bad. What do I need here? I need to close that quote and then print the variable area. And then here space, close the quote, comma, perimeter, like that. Okay, and then print diagonal, colon, space, close the quote, comma, diagonal, like that. Does that look good? I think that looks pretty good. So now let's run this thing. I will need you to hold your breath. What is the length of your rectangle? Hey, that looks pretty good. Well, let's just say it is 3, okay? And then what is the width of your rectangle? 4. All right. Why did I do that? Because I know that that triangle is going to be, the triangle is going to be a 3, 4, and I know the diagonal then should be a 5. It's a special triangle. So I do that special case just so I can make sure that this works. And so now we're going to hit enter and look at that. The area is 12. Does that make sense? Yes, 3 times 4 is 12. The perimeter is 14. Well, that would be 4 plus 4 is 8 plus 6 is 14. And the diagonal is 5. Boom, I've solved this rectangle. So that is the way that we would typically do this thing, okay? But you see, if you came in later, this is getting kind of complicated. So what do we want to do? We want to do the calculations in a function, okay? How do we create a function? Well, up here at the top, I'm going to define DEF, a function. What are we going to call this function? You can call it whatever you want, but I think I'll call it RECT for rectangle solve, like that. Now, for this function to do its calculation, what 2 things does it need? It needs to know the length. It needs to know the length of the rectangle and the width of the rectangle. Okay, it needs to know length and width. So I need to pass it that. So I'm going to say length and WID. Now, also, this is kind of like a for loop. You've got to end it with a colon. All right. Now, what I have to say is that the variables that you pass it, you don't have to name it the same. You don't have to name it the same. And so what I'm going to do is I am going to name them differently. And then when I call it, like I can come down here and let's say that, well, let me go ahead and write the math, and then I'll talk about passing the variables. But when I call the function, it's based on position. I could call rect solve and pass it L and W, and L, which is in the first position, will go into length, and W will go into width. And I just do this to show you, you don't have to name the variables the same in the call as you do in the function. And hopefully that'll make sense as we go through here. And actually, I like to call them something different just because I think it makes a little bit cleaner programming. All right, what do we want to do here? Well, up here, we want to say area is equal to length times width. Now, why length and width? Because that is what the function uses for the variable names. I will not use L and W. I'm going to pass L into LEN and W into WID, okay? Now I have the area. Now the perimeter is equal to the 2 times the length plus 2 times the width, like that, width. Okay, and then the diagonal is equal to what? The length, star star raised to the 2, plus the width, star star raised to the 2, and then I want the square root of that. So what do? I raise that whole thing to the 1 point divided by 2 point, like that. And now I have those 3 things that I want, right? So that looks pretty good. Now, since I'm doing the calculations up in the function, what I'm going to do is I'm going to take the calculations out down here. All right, I take those out. Now, you could think, well, why don't you put the prints up there? Because I want this function to just do the calculations, and then I want to print in my main program. What you could do is you could write a separate function to print, but for this illustration, what I'm going to just do, I'm going to do the print in the main program, and I'm going to do the calculations above. Okay, so now I have area, I have perimeter, I have diagonal, and those are calculated up in rect solve. So let's see, what we're going to need to do is now call that function, and so I'm going to say rect solve, and I'm going to pass it what? The L and the W, like that. And so rect solve will call this, it'll calculate area, perimeter, and diagonal. And L The first position is going to go into LEN, W is going to go into WID, and now this should calculate those things. So we're going to run it. And what is the length? It is 3. What is the width? It is 4. And we have a crash. It says area is not defined in line 12. So in line 12, it doesn't know what area is. So what happened? I calculated inside this function area, perimeter, and diagonal, okay? But what you have to see is when you define or use a variable inside of a function, it is a local variable, meaning that only this function knows what area, perimeter, and diagonal is. The main program is blind to those variables. Why? Because they are local variables. Well, how could I fix that? I could make them global variables. So up here I could say inside this, my variables, area, perimeter, and diagonal, I want to share them with the world, so I will make them global. What do I want? Global, area, perimeter, and diagonal. All right, and now let's run it again. What is the length? It is 3. What is the width? It is 4. And boom. Okay, you see it works. Now, the way I just did this is I just did this to kind of show you, but it is not a good way to program because really, right, we want to do modular programming, meaning that this rectangular solve, we want it to be its own little independent module. Well, what if I was also dealing with circles and I was calculating the area of the circle? Well, maybe my function for circle might use area too. And so if I make these parameters global, then, you know, the circle function might be changing the area of the rectangle. So what you really want is you really want to keep those variables local variables. And so this was not a good thing I did here, but I just did it to introduce the concept of local variables. How else could I do it? And the better way to do it is I pass it L and W, and then what do I want to do? I want to return the answers. And so what I'm going to do is I'm going to have the function return to the calling line, what 3 things? Area, perimeter, and diagonal, like that. Now, when I call this, it's going to return those values, so I have to give it the variables to put those things in. And what are those? Well, I want area, okay, is equal to. No, you know what I'm going to do, because I just want to show you that, again, just like I can pass things and I can return things, and they don't have to be the same variable name. So area, I'm just going to call A. And then how many values am I returning? I am returning 3 values, area, perimeter, and diagonal, and I'm going to put those in the variables A, comma, P, comma, D. Now, if I was just returning one value, I wouldn't have a comma. I would just return area, and it would go into A. Now, if I do that, I need to change my variables here, like so, and like so, and like so. Okay, now let's run this thing and see what happens. Okay, what is the length of your rectangle? What is 3? What is the width? It is 4. And boom, area is 12, perimeter is 14, and diagonal is 5. Okay, so now do you see, look how clean this is. This function is doing the work for me. This function is doing the work for me. Down in the main program, you can see that this is very readable, and I don't have to get into all the nitty-gritty of how the math is working. L is the length, W is the width, and then I get A, P, and D with rect solve. For rectangle solve, I pass it length and width. I get the area, the perimeter, and the diagonal back. What did I want? Area, perimeter, and diagonal. But now I get them back without having to worry about and remember and deconvolve all of what's going on with the math. Okay, so you see this is working much, much better. I think that is a much, much better way to do it. And hopefully you can see that this is cleaner. So what you want to start doing is you want to start thinking thinking when you're coding about what functional blocks you can build into functions, and then your main program starts becoming a lot cleaner because you're doing what you are just calling functions. You're just calling functions. Now, one more thing I want to show you, and what I want to show you is I want to show you that functions can call functions, because as things started getting more complicated, like if I was doing a whole bunch of stuff here, now I could make this function more modular by having it call other functions. Okay, so let's see how that would work. So what I'm going to do here, I'm going to take this stuff out and I'm going to call functions, and then we'll come back later and we will define those functions down below. But what I could say is area is equal to, I'm going to call a function, a new function I'm going to write, which is called rectangular area. What is it going to need? It's going to need length and width. Why did I pass it len and wid instead of L and W? Because here L goes into length, W goes into width, and what this knows is len and wid, so I use those, and I pass those to this new function, rectangular area. Now, what else would I need? I would need perimeter is equal to rect perimeter. Hopefully I'm spelling this right. What does it need? Length and width, like that. Okay, and then what else? Diagonal is equal to rect diagonal, and that is going to be past length and width, like that. And then what do I return? I return area, perimeter, and diagonal. Now, if I'm going to call these functions, I have to define those functions. So I'm going to come down here. I'm going to say define what? Rect area. Okay, what does it need? It's going to, and now I'm going to pass it back to, let's make it new. Let's say length, like that, and width. I could just use len and wid again, but I'm just getting you used to those names don't have to match. Okay, so what is that function going to do? Okay, this is the area, and so the area is equal to length times width, like that. Okay, and now what do? I return the area, like that, and so this area is going to go back to that area. And in fact, I like to show you that these don't have to be the same. So what I'm going to do is I'm going to call it A. So I'm going to return A. And here I will say A is equal to that, return A. A is going to go into area, and then area is going to be returned back to A here, if that makes sense. So that is the first one. What do we need to do now? We need to do the perimeter. So I'm going to say define rect perimeter, and then I'm just going to do L and W to make it a little simpler. And then what am I going to do? I'm going to say that P is equal to 2 times L plus 2 times width, like that. And then what am I going to do? I'm going to return P. Now what's the last one I need to do? Define rectangular diagonal. It needs the length and the length and the width, like that. Put our colon in, and then what is this going to be? It again is Pythagorean theorem. So I'm just going to call this one DIAG is equal to LEN squared. No, this would be L squared. L squared plus W squared. W squared, like that. And then I'm going to return diagonal, like that. Okay. Probably made some typos in there, but let's run it and see what happens. Okay, what is the length of your rectangle? 3. What is the width of your rectangle? It is 4. And 12, 14, 25. What did I forget to do? What did I forget to do? In the Pythagorean theorem, you have to take the square root, raise it to the 1 point divided by 2 point, like that. Let's try it again. Okay, what is the length? The length is 3. The width is 4, and 12, 14, and 5. Boom. We have a modular program. Also, what I want to show you here is there's something else that you could do. What if you just wanted the area? Well, what if you just wanted the area? I could come in and I could say that A is equal to, I don't have to call this rect solve. I could call just rect area. And I could say A is rect area, like that. How many values does rect area return? 1, A. And so I'm going to come down here. I'm going to change this back to, I'll call it AR, rectangular area. And now that it needs to know what? L and W. Okay. And then here I can't print P and D because I didn't do those. But you see, I can now either call the main one that solves the whole thing or just call the one that does what I want. And so let's look at this. Okay, what is the length? The length is 3. What is the width? The width is 4. Oh, yeah. I said AR here, like that. AR. Let's try again. Okay, so that would be 3, 4, area 12. Boom. Okay. Now, do you guys see how much cleaner this code is when we start doing functions? We pass the values to the function in the call, and then we return the answers, and then down here, we catch the answers. Okay, we catch the answers. So hopefully that makes sense. And hopefully you see the power that as we start writing more complicated programs, we want to do what? Modular programming, and we want to use functions. All right, guys. Now I need to give you all a homework. And I'm going to give you kind of a classic homework problem. And that is that what you need to do is you need to go in and you need to get a list of grades from the user, okay? And so if you're going to get a list of grades from the user, you need to what? You need to first ask him how many grades does he have, and then you need to enter those grades. Now, you might have 3 grades or you might have 7 grades, so where would you put the grades? You would put the grades in an array. Now, if you don't remember about arrays, go back to the class. I did a whole class on this earlier. I don't remember what the class number is, but look at the playlist. Go back and review arrays if you don't remember how to do arrays. But you want to put your grades in an array. Okay, so what would be a good, I'm going to give you a few hints here. What would be a good function to write? You would probably in your main program, you would ask for the number of grades, and then you would call a function like maybe called input grades, and then that function would input the grades into the array and then would return the array. Then what I want you to do is I want you to find the high grade, I want you to find the low grade, I want you to find the average of the grades, and I want you to sort the grades from highest grade to lowest grade. So like if you had 60, 70, 80, 90, if you input the grades as 60, 70, 80, 90, I want you to sort that and put them high to low, which would then become 90, 80, 70, 60. So I want you to take that list of grades and sort them into the proper order. Okay, now I'm going to share with you one of my biggest frustrations in teaching classes on YouTube. You see, that frustration is when I give you something like sort, that can be a little bit of a tricky function, but I want you to think through it because many of you over here, you have what you want to do, what the assignment is, and over here is what the solution is, but you don't have any connection between the problem and the solution. In your brain, those two things are not connected. Your brain isn't wired to do that, so it turns out to be very, very hard. But well, not very hard, but it's something that requires a little bit of thought. So as you're thinking through it, what is happening, you're making a new connection in your brain. You're wiring your brain to solve a problem. You're wiring your brain to problem solve. But instead of wiring your brain to problem solve, what do many of you guys do? You run out and say, oh, well, I looked this up and Python has a sort function, and it's a lot easier to do the sort function than it is to write a program that sorts things. What is the problem with that? You are not wiring your brain to solve problems. What do you do then when you come to a problem that there's not a canned solution for? You can't do it because you've never learned to problem solve. You've never learned to make those connections. You haven't wired your brain to look at a problem and create a solution. So I will not accept homework where you use the sort function. Similarly, there is a Python function that averages. Don't use that. Write a function. There's a Python library that will average an array, but don't use that. What I want you to do is I want you to write your own function that is like abnum for average numbers or something like that. You pass it the array, it figures out the average of those numbers, and it returns the average. So I would imagine that you would have four functions. One would input the grades. You would pass it num grades, and it would return the array that has the grades in it. The second one finds the high grade and the low grade out of the array, returns those. The third one looks at the array, calculates the average, returns the average. And the fourth one sorts your array to put the numbers in order and then returns the sorted array. And let's see, maybe, let's see. And then probably you could just print the things out in your main program. So I've given you a lot of hints here to kind of keep you organized, but see if you guys can think through this classic problem of how do you average numbers in an array and how do you sort an array. Okay, those are classic problems. And what I want you to do is I want you to figure out how to do that on your own. Because what I found is, like, even when I was in college, there were kids, and those kids were always looking for help on their homework. They could never think through things themselves, so they would find a help here, they would find a help here, they would do this, they would do that. They would go out into the job force, and they really weren't able to solve problems. And anytime they got a job assignment, they were always looking for some way to either get someone else to show them how to do it or find a solution, or rather than doing it themselves, want to say, oh, well, let's go get this consultant to do this. What I want you to be is I want you to be a problem solver. And the way that you become a problem solver is to write this program without using the canned functions. Sound good? I hope it does. Man, I hope you guys are having as much fun taking this class as I am making them. The next few lessons, we're going to be learning a little bit more about advancing our programming skills. So we're going to go from, from these writing functions to then we will actually learn how to write classes. We'll learn how to do classes and methods and things like that. So we're going to advance our programming skills a little bit. If you guys already know how to do this, it will be a good review for you. For some of you guys, it'll be the first time to do this. Hey, as always, I want to thank you guys that are standing with me on Patreon. Your support and your encouragement is what keeps this great content coming. Also, you can help us by leaving us a thumbs up. Helps us with the old YouTube juice if you leave a comment down below. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.